Now we will discuss how to compute the length of an arc, which is a piece of a circle. So suppose I have a circle, okay, like this one, and there's an arc, it's like a piece of the circle. I have that. Maybe that's not very clear, but let me see. So suppose I have this arc, and I would like to compute the length of that. The question is how to do so. How do you compute the length of that? Well, that's not hard. It's actually very easy to do, and this is all we have to do. We're going to, so we have, this is the end, this is the beginning and end, and we're going to consider the center of the circle, and we're going to connect the endpoints of the arc to the center of the circle. And that's going to form an angle, and that's called a central angle. Central because the vertex is at the center. And to find the length of this, we're going to use the measure of that angle. And there's only two steps in order to do this. So first step is we're going to find the circumference of the circle. So of course that means that we need to know the radius to find the circumference. So suppose we know the radius. And recall what is the formula for the circumference. The circumference of the circle is 2 pi r. Okay, then what you're going to do is you're going to, after you find this 2 pi r, which is the circumference of the circle, you're going to multiply it by the fraction that corresponds to the angle. By the fraction of the circle that corresponds to this angle. So that is just the angle divided by 2 pi, because that's the total in radians, or by 360, because that's the total in degrees, right? The whole circle is 360 degrees, or in radians, it is 2 pi. So you're going to take the angle and divide it by the total, 2 pi whether it's in if it's in radians, or 360 if it's in degrees. And you're going to multiply those two things, and that's it. All right, so find the circumference, which is 2 pi r, and then multiply by the fraction of the circle that corresponds to that angle. And that is just the angle over the total. The total is 2 pi if you're measuring in radians, and the total is 360 if you're measuring in degrees. Okay, then you simplify and it's done. That's all. Just one comment before we do the first example. In the very special case in where you're using radians, okay, this method could be done for either radians or degrees, doesn't matter. The procedure is the same. But in the case in which you're using radians, then when you compute the circumference of the circle, that's 2 pi r. And then because if the angle is in the radians, then you divide them by the total, means you divide by 2 pi. Then you could cancel that, and you would get theta equals r. So the length of that arc would be theta times r. Theta times r, or r theta. Okay, which is a formula in the book. And by the way, the length of an arc is usually denoted with a letter S. Okay, so the formula then would then be like I have it in this box, x equals r theta. So that's a formula that works only when you have radians. If you don't have radians and you still want to use a formula, well, you can't, because that formula is only for radians. But what you can do is you can change the degrees to radians and then use the formula. So that's one way. The other way is just do the procedure that I just explained. All right, so first example is find the arc length along a circle of radius 5 subtended by a central angle of 20 degrees. Okay, subtended means if this is the central angle, this is the arc subtended by the angle. All right, so this is what we have then. The length of the arc is 2 pi r. What is the r? The radius is 5 miles. So 2 pi r times the fraction that corresponds to the angle. The angle is in degrees, so angle over total, so if it's in degrees, you divide by 360. Once we simplify this, we're done. So you see this is very simple. To simplify this, you could use a calculator, but you're going to leave the answer in terms of pi unless they ask you to round it. It doesn't say here anywhere to round it, so we're going to leave it in terms of pi. So, okay, we're going to cancel the 0. And then we're going to cancel, we can cancel more, we can cancel a 2. So if I cancel a 2 here, I would get 1. I'm dividing by 2 to top and bottom, 1 and 18. Okay, so what do I have? Multiplying across, this will be 10 pi over 18. And that's not completely simplified yet because we can cancel another 2. Dividing by 2 top and bottom, you will get here a 5. And dividing the bottom by 2, you will get a 9. So that means the answer is 5 pi over 9. Okay, what are the units? It's miles. So this is the answer. If they don't ask you to round it, that's the answer. Don't round it if they don't ask you to. If they did ask you to round it, they will tell you how many decimals they want. So let's suppose they want 3. Then this would be, if you put this in the calculator, 1.745 miles. Okay? So this would be the answer if they ask you to round. And that's it. You see, it was very simple. Just find 2 pi r and then multiply by the fraction that corresponds to the angle. That's all. So let's do another one. The next one says, given a circle of radius 20 inches, find the length of the arc subtended by a central angle of 2 pi over 3. So this is the same type of problem, just in radians. Okay, but as I said, it's done exactly the same way. So first step is find 2 pi r. So 2 pi times r, the radius is 20 inches. So 2 pi times 20. And then we're going to multiply by the fraction that corresponds to the angle. The angle is 2 pi over 3. And then you divide by the total. It's in radians, so the total is 2 pi. And now we simplify this. Once we simplify, it will be over. We can cancel, know that we can cancel the 2 pi. So that's gone. So what we're left is 20 times 2 pi over 3. Now multiplying across, this is 40 pi over 3. And that's it. There's nothing else we can simplify here. So the units are inches. The radius was in terms of inches. So that is the answer. If they don't ask you to round, again, leave it in terms of pi, so that would be the answer. If they ask you to round, then put in your calculator. Let's suppose that in this one they ask for 2 decimals. If they ask for 2 decimals, so this would be, rounding to 2 decimals, 41.89 inches. Okay. All right. Okay, now let's do this example. This example is pretty neat. I really like it. This is a real application, like a real world application. It says, suppose that you know the coordinates of these 2 cities. So these 2 cities, Columbia, South Carolina, and Daytona Beach, Florida, happen to be on the same longitude, which is 81 degrees west. The latitude of Columbia is 34 degrees north, and the latitude of Daytona Beach is 29.21 degrees north. Using the radius of the Earth to be 3,960 miles, let's figure out the distance between these 2 cities. So it sounds complicated, but it's really, really easy because this is just an arc length problem. So you see, you have the globe of the Earth. So it's like a big circle. So I'm not gonna try to draw a big circle, but it's curved like that. And you have somewhere here, Colombia. In Daytona Beach further south. Okay, and they're on the same longitude. And then they tell us that this one is 34 degrees north, and then this one is 29.21 degrees north. Okay, north there above the equator. All right, so then we have to figure out the distance between the two cities, which is nothing but the arc length of that. Okay, so this is just an arc length problem. But for figuring out the length of that, we just need to find that angle. Now that angle is just pretty easy because that's just the difference. So we need to put this in the calculator real quick, or do it by hand. I'm going to put it in the calculator. 34 minus 29.21. We get that difference is 4.79 degrees. So the central angle is 4.79 degrees. And now we can do the problem. And this will take no more than a minute. Okay, so that's I just wrote it in the way. So this is going to be S equals 2 pi r. The radius of the Earth is given to us 3,960 times. You multiply by the angle that corresponds to the fraction that corresponds to the angle. The angle is in degrees, so the total is 360. Okay, now let's put this in the calculator. This is 2 times pi, okay, where's the pi there, times 3,960, okay, times 4.79 divided by 360. And you get 331.06 because it says round to 2 decimals. So we get 331.06. And this is in terms of miles. And this is an approximation, of course. So that's it. That's the answer. So given the coordinates, you can figure out the distance between two cities if they're on the same longitude. Something similar could be done if they're on the same latitude. Okay. All right, and here's the last variation of a problem that you could encounter. This one is like going a little bit backwards. In this one, in this particular problem, they give you the arc length and they give you the radius, and you have to figure out the angle. Okay, so they give you the radius and the arc length, and you have to figure out the angle. Another variation that you could also encounter would be that they give you the arc length and they give you the angle, and you have to find the radius. Right? So there's always three things involved in this calculation: radius, arc length, and angle. And given any two, you can figure out the third. Okay, so this is just a problem on. They give you two other ones, not the ones we've been using, and you figure out the third one. Okay, but this is not hard. Okay, so let's draw a quick picture. So we have arc, central angle, theta. I don't know what that is. We're gonna find it. The length, the arc length, is 12, and the radius is 8. The question is, what is theta? All right, we're gonna pretend for a second that we know what theta is, and we're just gonna do the process in the same natural order that we've been doing it so far. So we're gonna write the arc length is 2 pi r. 2 pi r. We know what r is, so 2 pi 8 times, and then you multiply by the fraction that corresponds to the angle. The angle, I don't know what it is, so I'm gonna have to write as theta. And then you divide by the total. whether it's you divide by 2 pi if it's in radians, and then by 360 if it's in degrees. So what is the total here? Is it in degrees or in radians? If you said radians, then you're right because it's right there. Okay. So it's in radians, so that means I want to divide by 2 pi, not by 360. All right, and then we simplify and we're done. I mean, we have to solve for theta, but it will be done really quickly after this. So we get S equals 8 theta. Okay, but now I know what S is, so I'm going to put it in there. S is 12, so this is going to be 12 equals 8 theta. Now divide by 8, you're going to get that theta equals 12 divided by 8, which is what? This is simplifying, dividing by 4, top and bottom, you get 3 halves. And that is the answer. The answer is 3 half radians. You don't have to write the word radians. Okay.